Alright gang, I'm going to solve about 36 problems or so to help prepare you for the fall final exam for geometry. So it should help a ton. Alright, let's get rolling. It's going to take quite a while. So you can fast forward, pause, rewind, all that. Alright, I'm including the learning targets. I'm going to give you a hard copy of this as well. Okay, why is angle C congruent to angle R? Now, if you're trying to prove triangles are congruent, then you can choose one of these. Let me get rid of that. So if you're trying to prove triangles congruent, these are shortcuts for proving triangles congruent. If the triangles are already congruent, you can tell these two triangles are congruent by side angle side. You can see that. And because they're congruent, that means that corresponding parts of congruent triangles are also congruent. So that means that angle C would be congruent to angle R because of CPCTC. So CPCTC is used after the triangles are congruent. This one, what we're looking for is how many lines can we draw such that we could fold the figure over and it would be exactly the same. So you have to think about this figure for a while. You have to look at the insides a little bit, the different layers, and eventually you'll come to the decision that the only line you can draw would be this line, where you could fold it over in half and it would be exactly the same. The next question is the rotational symmetry. And this is if I turn the figure around, if I spin it, rotate it, if you will, how many degrees can I rotate it and have it look exactly the same as it does right now? And this particular figure doesn't really have any rotational symmetry, so that's what we're going to say on this one. So we're going to say no rotational symmetry. Sometimes you can rotate an object 90 degrees, so 1/4 of the way around and have it look exactly the same. Sometimes you can rotate it, 1/2 of the way around, so 180 degrees. So you'll just have to decide on each figure which angle measure would work, but that's what you're doing. Okay, for this one we're trying to see if we take 5, -3 and we perform this translation, then what would the new what would the coordinates of the new image be? So what we have to do is we have to take the 5 and we just subtract 6, and then we take the -3 and we add 2 and see what the new coordinates would be. So 5 minus 6 is -1, -3 plus 2 is -1, so the new coordinates are -1, -1. Okay, we're trying to fill in the blanks here. So the slopes of parallel lines are the same, and the slopes of perpendicular lines are opposite reciprocals. I like to say opposite reciprocals. Some will say, well, it's not letting me write, so hold on a second. There we go. So opposite reciprocals. Some will say inverse reciprocals. And so if we have one line that has a slope of 2/3, the one parallel to it would be exactly the same. So of course it would also be 2/3. And then if it's perpendicular, it's going to be opposite reciprocal. So that would be -3/2. Okay, if this figure is reflected across the x-axis, let's try to figure out where it would be. So when we reflect it across the x-axis, it's exactly the same number of units. This is the x-axis, by the way, right? And so we reflect it over there so that we can tell this is 2 units down. So then we would just go 2 units this way. So the new coordinates of A would be A prime, and that would be 4, +2. And then B would be, it looks like right now it's 0, -2. So then it would be exactly 2 units above the x-axis, so then it would be right here, and that would be b prime. And the coordinates would be 0, positive 2. And then this one, the 1, 4, would reflect also across the x-axis. So since it's above the x-axis, it would be below the x-axis. So it'd be 1, negative 4. And that would be that would be C prime, we call it. And so then we can connect those. So the shape would look like this. And the question is, let's see, find the coordinates of A prime. So A prime would be 4, 2. And then the length of A prime, B prime there, that segment, is going to be exactly the same. So when you reflect an image, it's a rigid motion. It doesn't change the lengths of anything of the figure. So right now, we just want to figure out what the original length is. We can tell that it goes from 0 here all the way to 4. So that's 4 units. So that's exactly the same length that it will be when it's reflected. Okay, we want to write an equation in slope-intercept form. So whenever you want to write an equation, you always need a slope. So make a note that we always, of course, need a slope. Not so sure I like my stylus, sorry. So give me 1 sec. Not working great. Try this other one. Okay, so we need a slope. So we can pull the slope out of this one because the line is parallel, so it has the same slope. And then we also need a point. So a point and slope. So, and then we're going to want to use the point slope form. So the point slope form is y minus y sub 1 equals the slope. And then x minus x sub 1. So we're going to go y minus the 6 equals the slope, which is negative 2/3, and x minus the negative 8. So because that's a negative negative, that's going to be plus 8. And then we're going to distribute, because we're going to try to get it into slope-intercept form, which is y equals mx plus b. So we have to kind of do a little fraction action there. So let's kind of work it out. So this is going to be negative 2/3 x plus, and when you multiply that, think of this as 8 over 1. So on the top, it's going to be negative 16 over 3. And then we still have the y minus 6 over here. And then we're going to have to add 6. So we add 6 and add 6. Now this part I probably would do off to the side. So I'm going to figure out this fraction work off to the side. So this is going to be negative 16/3 plus 6. Now we need to have a common denominator. So it's a great idea to multiply by 3 over 3. That's how you can get the same denominator. So it's going to be negative 16/3 plus, and that's going to be 18 because you multiply those together. So that's 18/3. And this equals 2/3 because now they have a common denominator. So then we can take that answer over here and we can say plus 2/3. So that's our answer there. Okay, for this one, we want to label what we're given. So BOC is, oh, didn't want that. So BOC is x plus 3. I'm on the struggle bus with my stylus. That's really, all right, x plus 3. And then AOB is 4x minus 7. And then it told us that AOC, which is this whole angle is equal to 21. So that helps us set up our equation because we know that we could add those together. So we're going to say 4x minus 7 plus x plus 3 has to equal 21, and then we're going to solve for x. So we're going to add our x's together, that's 5x. We're going to add our numbers, so that's negative 4. And then we're going to add that 4 over. So we have 5x is equal to 25, and then we're going to divide by 5. So x is going to be equal to 5. Let's make sure we answer the question. So solve for x, so we got that part. And then AOB, so angle AOB, the measure of angle AOB, is equal to, let's see, 4x minus 7. So that's going to be 4 times x, which we found it to be 5, and then minus 7. So that's 20 minus 7, which is 13. So that's our other answer. So 2 good answers there. Okay, we're going to solve for x and y here. So we can tell that we have a couple of isosceles triangles, and we know that the base angles then would be congruent, so that's 40 as well. And then we know that this is just a triangle, so we know it has to add up to be 180. So whatever you think is the easiest for this one, you know, if you want to come up with an equation, you can say that x plus 40 plus 40, of course, has to equal 180. And then x plus 80 equals 180. And so x has to be 100. Or if you just want to think, I'm gonna take 180 and I'm gonna subtract 80, you know, and get 100. So this is 100. And then we know, since this is a vertical angle, that this is also 100. And then we know that this is y and this is y. And we have more tick marks here. So we know that these are congruent. So that means we can do 180 minus the 100 that we already have, and that equals 80. And then if you want to, you can divide by 2 to figure out what each of those y's are. So divide by 2, and you get 40. Okay, so x equals 100 and y equals 40. And of course, you can set up an equation for that one as well. Y plus y equals 100 equals 180. Do whatever works for you. This is what the equation looks like. All right. This one we're trying to figure out, if our goal is to prove the triangle's congruent by side angle side, what more do we need? So we would need to have this side would have to be congruent to this side. So we want to state it exactly right here. So we're going to say that we're going to need, just see if I state it the same way. So I'm going to say that CW would have to be congruent to BU. Wow. I'm really struggling with my stylus. Okay. And then so let me erase that. So see the side angle side there. And then next, if we wanted to do the angle side angle, what we would want is we would say, hey, we've already got an angle, we got a side, we really need to have this angle, and we have an angle, we have a side, we really need to have that angle. So we would want to say that angle O would be congruent to angle U. Okay? Now, if our goal was to prove the triangle is congruent by angle side, then we would need to have an angle, and then a side. It has to be in that order. So it'd be angle, and then a side. So that means we would need angle W to be congruent to angle G. And let me just write those other ones back in there. CW is congruent to BU. Okay, good on that. All right, so this is an angle bisector, this IK here, and it bisects this angle, HIJ, and the theorem says that if there's ever any points that are on the angle bisector, that it's the same distance, so that any point that's on the angle bisector is the same distance from the sides of the angle. So we're going to be able to set these equal to each other. So let's do 2x plus 10 is equal to 6x minus 18. We're going to subtract 2x. So minus 2x, minus 2x. All right, that's going to be 10. This is going to be 4x minus 18. And then we're going to add 18. So this will be 28. This will be 4x. Then we're going to divide by 4. So x will be equal to 7. Let's make sure, see what we're looking for here. So just solve for x. So that'd be it. Okay, on this one, we're given the vertex. So I would always draw the triangle just so we can kind of visualize it. So we have this triangle. The vertex angle is the one here, right up at the top. So this is 96. And if it's an isosceles triangle, that means those are the two legs. It would be congruent. And we know the base angles are always congruent. So then we would have those congruent. So you can come up with a little equation. So you could say x plus 96. We know that that has to equal 180. So 2x plus 96 equals 180. Of course, these are degrees. And 2x equals, so what's 180 minus 96? So 180 minus 96 is 84. And so x has to be equal to 42. And we know that they're always the same, so these base angles, so 42 and 42. And then, yeah, so that's how you would do it. And then if you knew this angle, you'll be able to figure it out. All right. Okay, we get to some special angle measures with parallel lines and transversals. So we've got a couple of lines that are parallel. So we have these ones are parallel, and we have these ones are parallel, J and K. All right, so all these lines here are parallel to each other. So, or at least a couple pairs here. And so 5 and 10, let's try to figure out the relationship there. So there's 5 and there's 10. So these would be alternate interior angles, and they're supposed to be congruent when you have parallel lines. So that means that they are the same measure. Okay, we're going to solve for x and y, so similar to that other one we had. So we already got the 85, and we know this one's x, and this base angle's x, so the base angles are congruent. So really all we have to do is we can set up an equation, or we can just do 180. This time let's do it this way. So let's do 180 minus 85, so you can just do that on your calculator. 180 minus 90, or I'm sorry, 180 minus 85 is 95. And then we know that it has to share the degree measure that's left over between two angles. So then we can divide by 2. And we divide that by 2, and we get 47.5. So that means that x right here is 47.5. And then see how these two angles here, they form a straight line, these two here. So that means they have to be supplementary. They have to add up to be 180. So that means all we need to do to solve for y is just do 180 minus 47.5, and that should be 132.5, and that's what y equals. That's how I think is the easiest way to do it. Okay, define acute, right, obtuse angles. So an acute angle is when the measure is less than 90, 0 to 90 really. So we'll say a measure is less than 90. Okay, and greater than 0. And then if it's a right angle, we know that the measure equals 90 degrees. And then we know that an obtuse angle is the big one, and the measure is, it's greater than 90, and it's actually less than 180. And then we have also a straight angle. So a straight angle, remember, is the one that equals 180. So the measure is 180 degrees. Okay, which figure is of figure, let's see, which figure is the rotation image of figure 2? So if we took, the question basically is, if we took this image and we rotated it with the center, with the origin as the center of rotation, which figure could it be? So this one we kind of have to picture, if you thought about, spinning it around like with patty paper. If you need to do that to help out, that would be great to visualize it. But if you could picture this image being rotated from where it is now, and it rotates 180 degrees, it would actually end up here. And this is the only image that kind of has the correct orientation, if you will. So all the other ones are just off the way they're, just kind of the way that the other sides of the triangle aren't going the right direction if it's spun around the origin. So this is the one. Okay, for this one, what I would do is kind of draw the situation. So it says that A is parallel to B, so I would just say, hey, this is A right here. So I would just label it. So this is line A, and it says that it's parallel to line B, so just draw another line that looks like it's parallel to it. So this would be line B, and then it says that B is perpendicular to C. So the only way that B could be perpendicular to C is if C would run this way, and that would show that it would be actually perpendicular like that. So we could label this line C, and then it says C is parallel to D, so then we would draw another line that would, definitely look like it's parallel to C, and I would label this one D. See how those two are parallel to each other? And then the question is, and just keep drawing the situation as it's given like that, and then it says what must be true about line A and D, and then you just look at it and you can tell. They'll either probably be parallel or they'll be perpendicular. So for this one, if you look at it, you can tell you've got A right here and you've got D right there, and those would actually be perpendicular, you can tell. So we would say that A is perpendicular to D. So make sure you're familiar with the notation like that. This, of course, that's parallel, and that's perpendicular. Okay, so we have the special relationships, that are created here with the angles, because we have all these, we have the same given as before, so M is parallel to N, and j is parallel to k. So let's try to look to see what the relationship is between 3 and 15. So let's see, 3 is right there, and 15 is right there. Now what they are is these are on the same side of the transversal. So see, the transversal is the line that goes through like this, and these are the parallel lines. And they're on the same side, and whenever they're on the same side, they're going to be supplementary. So these are what we call same side exterior. So same side exterior. And again, when they're same side, they're supplementary. So that means they add up to be 180. So if we take since they add up to be 180, what we can do is we can just do 180 minus 69, and that'll be how much angle 15 is. So let's do that. So that would be what, how much is that? 111, if I did that right. Yeah, so 111. Okay, so same drawing again. This time they're looking at angle 5 and angle 7. So these ones, look at the lines here that are parallel. And I wonder if that email notification comes up. I hope not. So this one is, these are corresponding angles. They're in the same location, if you will, kind of like the bottom left, bottom left. So corresponding angles are congruent. So corresponding angles congruent. And if they're congruent, that means we can set them equal to each other. So, and solve for x. So let's say 4x plus 20 is equal to 2x plus 40. And then we use our awesome algebra skills. So we subtract 2x. And that gives us 2x plus 20 is equal to 40. And then we're going to subtract 20. So we got 2x is equal to 20. And then lastly, we divide by 2. So x is 10. How does a person construct the in-center of a triangle? So when you want to do the in-center, let's just say we have a triangle here. If you want to find the in-center, what you do is you have to construct the angle bisectors. So these are the angle bisectors, and they would meet up. So what you'll need to know is that you need to construct angle bisectors for this one. And on a different slide, we'll talk about the, like the actual construction of what do you do to construct the angle bisectors. Okay. But make sure you know all of the different points of concurrency. How do you get the circumcenter? That's by, constructing the perpendicular bisectors of each of the segments. So kind of review those. Okay, line A intersects N, M, and L. Which two lines are parallel? So what you're looking for are some special things, like maybe alternate interior angles being congruent, or maybe corresponding angles being congruent, or maybe same side interior angles being supplementary, so anytime they're on the same side, they need to be supplementary to be parallel lines, and anytime they're on the opposite side of the transversal, they need to be congruent. So when you look at this and you see, hey, I've got 86 and I've got 86, then this would be the transversal, and then these would be the parallel lines. So we would be able to say that N and M are parallel. So N is parallel to M, and that's because of the alternate interior angles being congruent. Okay, we're trying to see what theorem or postulate, would prove that these two triangles are congruent. So we want to kind of mark this up a bit. So T is the midpoint. So T is the midpoint of IF. That means that these two segments would be congruent. And then if it's also the midpoint of PA, that means these two segments are congruent. And then, of course, we would have the vertical angles would be congruent. So these would be congruent. And then you can tell that we would have enough to prove these two triangles congruent by side, angle, side. Okay, we want to solve for x, and since we know that EG is the perpendicular bisector, then we know that any point that's on the perpendicular bisector is equidistant from the endpoints of the segment. So this segment that's right here, it has endpoints, and so any point that's actually on this perpendicular bisector is equidistant. So all that to say, we can just set these equal to each other. So x plus 11 is equal to 27, and then we just have to subtract 11, and so that will be, subtract 11 here, so that should be 16. Let's see what we're looking for here, solve for x, so that's it. Okay, construct the angle bisector. So of course for this, we need to, have a protractor and everything, but what you'll have are just the steps shown on the final exam. So the first thing you do is you take your compass and you put the sharp part, obviously right here, and you put a little arc measure there and an arc measure right there. That's your first step. Then you move your compass and you put the sharp part right there. So you put the sharp end here, and then you put a little mark kind of in the center there, and then you move it to this part, to this mark here, and then you put a little mark in the center there. And then you take your straight edge and you connect from there, whoopsie. You take your straight edge and you connect from there to there, and that would be a perfect angle bisector. So it's kind of in those steps. And if you need more help, you can go to this, you can go to this website. Remember that link that I have on Canvas. Okay, these points are given, and we want to see what the relationships are, and then just read what they, what relationship they want. So AC, so let's figure out, the only way to determine the relationship between these two segments is to calculate the slope. So remember the slope formula you'll need to have memorized still. So let's see, we got, oh man, this thing is, m equals y2 minus y1 over x sub 2 minus x sub 1. So this is how we calculate slope. All right, so we want slope of AC. So slope of AC is equal to, let's use our coordinates here. So we got A and C. Struggle. Okay, so we're going to subtract the y's on top. So we're going to do 3 minus 0. And then we're going to do the x's on the bottom. So we're going to do 0 minus a negative 2. So that would be 3 over 2. And then now let's do the slope of BD. So slope of BD. So that would be equal to 0 minus 3. And then we got 5 minus 3. So that's negative 3 over 2. So I would say they would be neither. So they're not the same slope, and they're not opposite reciprocal slopes. They are opposite signs, but they also need to be flipped fractions. So this would be neither. Okay, so we need to do a little proof here. So let me kind of set up a little structure. So we'll have our statements, and then we'll have our reasons. I'm not sure how neatly I can write this. We'll see. Okay, so let's kind of mark up what we have. I usually do that first. So UP is congruent to TU. And then we have that Z is the midpoint. So if that's the midpoint of that segment on the bottom there, that means that we know that this would be congruent to this. And then the reason why we could prove the triangles are congruent is because we know that this third side would be congruent because of the reflexive property. So that's pretty much it. They're going to be congruent by side, side, side. So now it's just a matter of us kind of getting the steps down exactly. So let me kind of catch up on my solutions here just so I can do it as precisely as possible. So first step, we're going to say that we've got, I found the wrong spot. That's what I did. Give me 1 second. All right, so I'm going to say, we're going to go ahead and use the given. So we're going to say that UP is congruent to TU. And the reason for that is it's given. And then second, we're going to go ahead and use the other given. So we're going to say that Z is midpoint of TP. Again, given. And then third, the reason why that helps is because when it's the midpoint, then we can say the segments are congruent there, that it breaks up. So ZP is congruent to ZT, and that's really the definition of a midpoint. And then we can go ahead and use that reflexive property. So we can say that UZ is congruent to UZ, and that's reflexive. And then we've got it. We've got our three sides. So we can go ahead and say that the triangles are congruent. So we can say triangle ZUP is congruent to triangle ZUT, and that's because of side, side, side. All right, so which angle is corresponding to angle 6? And that is, I think I might have forgotten to write that they are parallel. So M is parallel to N, let's say. So M is parallel to N. So which angle is corresponding to 6? So 6 is kind of in this bottom left spot, and 3 would be in that same spot. So we would say angle 3. Name one pair of alternate interior angles. So we could say either 2 and 6, angle 2 and angle 6, or we could say 5 and 4. So angle 4 and angle 5. And then let's try to find a measure here. So 4 and 6. So you'll notice that 4 and 6 are on the same side of the transversal. So that means that they have to be supplementary. So these are, just to put a note here, these are same side interior angles. And they are supplementary. And that means then we could just do 180 degrees minus 54, and then we'll be able to figure out the angle 4. So that would be 6, and I think I borrowed, so that would be 126. Okay, this one, same thing. M is parallel to N. So I need to put that in there. And we're going to say, let's see what the relationship is between 3 and 8. So look at 3 and 8. Notice how they're on the same side of the transversal. So when they're on the same side, they are supplementary. So I'm going to make a note that this is same side exterior angles, and they are supplementary. So that means we need to add them together and say they equal 180. So x plus 30 plus 3x plus 30 equals 180. Okay, so we're going to add the x's together. So we've got 4x, and then we've got plus 60 equals 180, and then 4x equals 120, because we're going to subtract the 60, and then x would be 30. All right, so let's label what we have. This is going to be the Midsegment Theorem. That's what we're utilizing here. So make a little note. This is the Midsegment Theorem. Okay, it basically just means that this right here is going to be half of this whenever these are midpoints of the legs of the triangle. So let's see what we have here. We have AB is 14, so that's labeled. And then CD is 22. So, I mean, we already know then that this is half. So then this is 11. And this one's 14 because they have a little tick mark there. So then we'll just answer the questions. So EB, we said, was 11. And then BC is 14. And then AC is just the combination of those two. So 14 plus 14, so 28. Easy peasy. Okay, so this is a little proof. We're trying to fill in a little bit, fill in the blanks. So angle 1 and 2 are supplementary. I mean, you can tell they form a straight line here. So, and it's given that angle 1 is 135. So it does make sense that if this is 135, that this would be 45, but we want to kind of prove it. So we run through the steps. So step number one, angle 1 and angle 2 are supplementary. And then the next step says that it's given. Well, there are only two things given. So we know that that next step would be the measure of angle 1 is equal to 135. And then the next step, wow, it's really hard to write with this stylus. So at least on that page it is. That's weird. Okay. Try this other one. Nope. That one's not working. Okay. So, and then measure of angle 1 plus measure of angle 2 equals 180. How do we know that? Well, that's the definition of supplementary. So that's definition of supplementary. And then they used a little substitution property on the next one because they replaced the measure of angle 1 with what they knew to be true, which is 135. And then the last step, they went from here to here. How did they do that? Well, they subtracted the 135. They subtracted the 135 from each side. Because if you subtract 135 and you subtract 135, you can see that you would have just the measure of angle 2 is 45. So for that step, we just put subtraction property. So then you just look for which answer has all those things, and this one should be C. All right, let's see if I can find my page. I haven't found it for a long time. Okay. All right, so we're going to need to sketch this one so we can figure out what's up with this reflection. So let's plot the point negative 1, 4 to start off. So negative 1, 4 would be like right here. So this is A, and it's negative 1, 4. Okay, now if we reflect it over the line y equals negative 1, let's try to picture this. So here's the line, this is the line y equals negative 1. Okay, remember, whenever they're y equals, they're horizontal lines. So y equals negative 1. Think about how many units away this is. So this is, just count the units. So from 4, it's right here at 4 right now, and then it goes all the way down to negative 1. So that's 5 units. So from there to there, that's 5 units. So then that means it would be reflected 5 units this way. So then the new coordinate would be A prime, and that means it would be 5 units less than negative 1. So then it would be down here. It would be down here at what? It would be, let's see, 5 units down. So it would be negative 1 minus 5. So that would be down here at negative 6. So this would be, I don't know why I drew a line down there, sorry. And we're reflecting it over the line, and it's just a point, sorry. So the point would be negative 1, comma, and then it would be negative 6, because again, this would be 5 units, and this would be 5 units, so you have to go 5 units lower than that, so negative 1 minus 5. All right, the next one says that it's going to reflect over the line y equals negative 5, so that means we would have to draw the line y equals negative 5 to picture it, which would be like right here. And this is y equals negative 5. And try to figure out how many units away the A prime is from that right now. So can you tell that it's just 1 unit away? It's 1 unit away. So that means it would be reflected 1 unit on the other side of the line. So it would be 1 unit above the negative 5. So A double prime would be negative 1, and then it would be negative 4. Okay, so that would be where the image would be. So the answer would be negative 1, negative 4. What you'll have to figure out is you'll have to figure out what set of, what composition of reflections would actually give you the same answer. So you'll have to do that same kind of thing to figure out which of the multiple choice, sets of reflections would get you to the right location. It'll give you a location that you're trying to get to. So you'll have to kind of, physically work it out like that. All right, we're getting there. Properties of rectangles. Now remember that rectangles have all the properties of parallelograms. So let's just make a note of that. That it has all properties of parallelograms. So if you want, I can kind of refresh those, but my stylus is not working great. So then the extra things that are true about rectangles is that it has all angles are 90 degrees. So the 4 angles, obviously, these 4. And then also what's interesting or extra about rectangles is that the diagonals are congruent. So diagonals are congruent, and that's not true, of all the parallelograms for sure. So diagonals are congruent, so we're saying we've got the diagonals here and they're congruent. Okay, I don't want to be misleading on that, because already with parallelograms we already have all those other properties, such as I'll just kind of mark them on here. So we have opposite sides are congruent, and we have opposite angles are congruent, We have opposite sides are parallel. We have consecutive angles or supplementary. And then we have that the diagonals actually, they bisect each other. So they cut each other in half. They're not congruent necessarily, they just cut each other in half. So like this would be congruent to this would be congruent to this. Okay. Okay, it's a good idea to memorize this flow chart. So I thought I would include it here. It's got all the properties of all of the quadrilaterals. It's just a great idea to understand kind of the hierarchy. And so just keep in mind that anything below, like a rectangle and a rhombus, these of course have all the characteristics of the parallelogram. And then if you have something like a square, it has all the characteristics of a rectangle and a rhombus, which is, you know, the combination, it has all the properties of a parallelogram. So you can think of a square as a combination of a rhombus and a rectangle. And then a kite, you know, it's totally separate, it's not a parallelogram. And then a trapezoid just has, you know, exactly one set of parallel lines, parallel sides. And then isosceles is special because at least the legs are congruent, and then it also has the diagonals are congruent. Okay, this is given as a parallelogram. So angle T and angle S are given. So it looks like these two are the ones that are given. So they are right next to each other. So they're not congruent, they're supplementary. So we're going to say they're supplementary. So 3x plus 10 plus 6x minus 10 is equal to 180. And that means 9x, looks like 10 minus 10, so that's gone, equals 180. So x looks like it's 20. All right, so let's figure out, so we want to figure out what angle R is. So really, we just need to figure out what angle T is, and then they would be the same. So let's figure out what angle T is. So measure of angle T is equal to 3 times x, so 3 times 20 plus 10. So that's 60 plus 10, or 70. And then, of course, these are congruent. So that means that the measure of angle R is the same. I'll make a little note here that measure of angle T is congruent to the measure of angle R. Opposite angles. Okay, so we have some always, sometimes, or never to answer here. The diagonals of a parallelogram bisect each other. That's always true. Exactly one pair of opposite angles in a rhombus are congruent. That is not true. It says that exactly one pair, so both pairs of opposite angles in a rhombus are congruent. A trapezoid is a quadrilateral. That's always true. It has 4 sides. A quadrilateral is a trapezoid. It doesn't have to be a trapezoid. It could be any of the other ones. The diagonals of a rhombus are perpendicular bisectors of each other. Yeah, so actually this is a rhombus, and the diagonals, they are perpendicular bisectors of each other. So they cut each other in half, and they're perpendicular. So that's the combination there. So that would be always. A kite is blank a parallelogram. So a kite is just not, it's never a parallelogram. So never. A rhombus is always a parallelogram. So remember, a rhombus is below a parallelogram on the tree diagram. Okay, this quadrilateral, we need to figure out really what it is. So I would say you should plot the points and and then do some calculations to figure it out. So let's plot some points. So we have -3, 1 right there. That's Q. That's messy. Okay, then we have r, which is 4, -3. So r is 4, -3. And then we have 4, -5. So that looks like it's there. So 4, -5. And that is s. And then we have t, which is -3, -1. Okay, so let's kind of draw that. Okay, so it looks like a parallelogram. So to ensure that, we would have to calculate some slopes. So let's figure out the slopes here. So we're calculating all kinds of slopes. So I'm going to say slopes. So slopes of, let's do QT. It's going to give me trouble on the last one. So slope of QT, I caramba. Let's see, subtract your y's. So actually this looks like an undefined slope. So it's going to be 1 minus a -1. And then on the bottom it's going to be -3 minus a -3. So it's going to be 2 over, it's -3 plus 3, so 0. So undefined. And then let's do the one that's straight across from it. So let's do the RS. Oh man, this thing is, whew. So RS, it is, looks like -3 minus a -5, and then 4 minus 4. So again, on the top, it looks like it's going to be 2 over 0, or 2 over 0. So undefined. So we've got parallel there, parallel, 2 vertical lines. All right, and then the next ones, we could see if, so these are parallel. And then we want to see if the other ones are parallel, so that would be QR. And that would be, let's see, subtract the y's. So 1 minus -3, and then -3 minus 4. So that looks like it would be 4 over -7. So that's QR. Now let's do TS. So TS, it would be -1 minus a -5, and then -3 minus 4, and that would also be 4 divided by -7, so we'd have parallel there. Now we know that this is not it's not a rectangle because the slopes are not opposite reciprocals, so not a rectangle. I guess the only other thing, it could be a rhombus, so we would probably need to check the diagonals, or we would just check the diagonals to see if they're opposite reciprocals, to see if they're perpendicular. Sure doesn't look like they're perpendicular, so, but you do need to, on your celebration or on your final, you want to check those slopes and see if they are opposite reciprocals. So maybe I'll do it real fast. So let's see, Q. I'm just not thrilled about this stylus, sorry. So on the top, I have 1 minus a -5, and then, let's see, -3 minus 4. So that would be 6 over -7. And then the other diagonal is TR, and that's -1 minus a -3, and then -3 minus 4. So that's 2 over negative 7. These are not opposite reciprocals. So not a rhombus. So not a rhombus. And like I said, these are not opposite reciprocals. So, and parallelogram is what it is. Okay? So when I say not opposite reciprocals, I mean this was undefined, and this was negative 4/7, so not opposite reciprocal, so not a rectangle. Okay, I think that might be it. Where's the easy button? Yeah, that's it. So last thing I would say is good luck. Okay? Awesome.